Okay. You must have solved the first 20 questions. So let's look at the solutions of the next 20 questions. We have already covered the first 20. So let's look at the 21st question. It's about upstream and downstream. A man can row his boat downstream at a rate of 15 meters per second and upstream at 16 kilometers per hour. Find the speed of his boat in still water. If you look at both the speeds, upstream and downstream, one of the speeds is given in terms of what meters per second, and the other one is given in terms of kilometers per hour. So you'll have to convert that. Yes or no? Look at this. A man can row his boat downstream at a rate of 15. So downstream speed should be written as u plus v. It's given equal to 15. So I need to convert this in terms of what? Kilometers per hour. So I'll multiply it by 18 by 5. This will give you how much? 54 kilometers per hour. And upstream speed is u minus v, that is already given equal to 16. So two equations, two variables. When you add this, you will get the value of u. Looking for what? Find the speed of his boat, that means u. So we'll say 2u is equal to 70. That means u is equal to 35 kilometers per hour. So my answer becomes third option. This was a very easy question. Let's look at the next one. A boat moving upstream can travel a distance of 48 meters in 12 seconds. Upstream, that means I'll have to take u minus v, while he'll take half the time if he has to travel twice that distance downstream. The distance is 48. Let's say the upstream speed is u minus v, so this becomes 12. So can we say u minus v must be equal to 48 by 12, that is 4. All the values will be in meters per second. The second statement says that will take half the time, that means 6 minutes, to cover twice the distance. Twice of 48 is 96. So we'll get u plus v here. So I'll say u plus v is equal to 96 by 6, that is equal to 16. Again I'm left with two equations. So you're looking for the value of u. Let's add these two equations. What you'll get? 2u is equal to 20. That means u is equal to 10 meters per second. So the correct answer becomes first option. Let's look at the next one. A man can row 50 km upstream and 72 km downstream in 9 hours. So total time taken is 9 hours. How do we write it? 50 kilometers with the speed of u minus v. The next 72 kilometers with the speed of u plus v. The total time will be 9. He can also row 70 km upstream. So how do we write it? 70 by u minus v plus 90 by u plus v is equal to 12. Now find the speed of the current. That means I'm looking for the value of u. How many variables are there? Two variables are there. How do we write it? It's better to replace this 1 by u minus v by x and 1 by u plus v by y. So this equation will become 50x plus 72y is equal to 9. And this equation will become 70x plus 90y is equal to 12. Two equations, two variables can be solved. How do we solve it? I'll multiply this equation by 7 and this equation by 5. So the new equation will be 350x plus 7 into 70, 490, 490 plus 14, that is 504y is equal to 63. The second equation will be 350x again plus 5 into 90 will give you 450y is equal to 60. When you take the difference, what you will get? This will be cancelled out. This will be 54y is equal to 3. So we'll get y is equal to 3 by 54. That means 1 by 18. When you put the value of y here, you will get the value of x. Let's solve it for x. 350x plus 504 into y, and the y is 1 by 18 is equal to 63. Can I cancel out 504 by 18? 18 into 2 will give you 36. Then you will get 144. 144 means 18 into 8. So 350x is equal to 63 minus 28, that is 35. So x becomes 1 by 10. What was x? 1 upon u minus v. So u minus v will become 10 and u plus v will become 18. When you add these two equations, you will get the value of u, that is 14. And what is the value of v? You will get v equal to 4 here. So the answer is 14 kilometers per hour or 4 kilometers. 14 kilometers per hour is the speed of boat, and speed of current will be 4 kilometers per hour. I hope this is clear. It was an application of what? Equations, where you replace the reciprocals by variables here. Okay, let's look at the next one. What's given here? A to B is a 300 kilometers downstream journey. Okay, this is 300 kilometers. It flows at a speed of 5, so the speed of the river is 5 kilometers per hour, while the speed of both P and Q are given equal to what? 3 am. They are given equal to 25. So P will start from here, Q will start from here. They'll keep moving towards each other. They'll meet at a point, let's say at point C. Then they'll cross each other. Then again they'll reach at their destinations and they'll take a U-turn. They'll meet for the second time, third time, and so on. So what's the question? Find their first two meeting times here. So what would be the relative speed for P? Speed of P is 25 and moving in a downstream part, so I'll have to add 5 here. And for Q, the upstream speed will become 15 minus 5. That is equal to how much? That is equal to 10. Yes or no? So at what time they'll meet for the first time? So I'll directly say time is equal to distance, that is 300 kilometer, and the relative speed would be how much? For P is 25 plus 5, that is 30. For Q is 15 minus 5. 15 minus 5 will give you 10. They are moving towards each other, so I'll have to add 10 here. This becomes 300 by 40, that is 7.5 hours. Yes or no? And 7.5 hours in starting time was how much? It was 3 am. When you add 7.5 and 3 am, it give you 10.5 hours, means 10:30. The first meeting time would be 10:30 am. Now they'll cross each other. I cannot apply the formula here, this one, 2n minus 1 into d by x plus y. I cannot apply it here because if you look at the ratio of their speeds, the effective speed of P is 30 and for Q it's 10. The ratio is more than 2, and if the ratio is more than 2, you cannot apply this formula. Yes or no? So you'll have to do it manually. At what point they'll meet each other? That would be 7.5 hours. So out of 300 kilometers, 203 parts will be covered by first person and 1 part will be covered by the second person. That means P will reach here. P will cover how much distance? 7.5 into effective speed was 30. So distance covered by P would be 30 into 7.5. That is how much? 225 kilometers. Then Q will cover the remaining 75 kilometers. So if you draw it again, I can say that this would be their first meeting point. P will cover 225 kilometers. Q will cover 75 kilometers. Q will go like this and P will go like this. So P needs to cover 75 more kilometers while Q needs to cover 225 kilometers to reach their destination. How much time P will take to cover these 75 kilometers? Time taken by P will be 75 by the speed of P. That was how much? 30. So 75 by 3 will give you how much? 30 will give you 2.5 hours. So after 2.5 hours, I can say that P will reach here, but Q will not reach here. Yes or no? Q will cover how much distance in 2.5 hours? 2.5 into effective speed of Q. This was how much? 75 kilometers divided by speed. Now distance covered by Q in these 2.5 hours would be 2.5 into speed of q, that is 10. So q will cover only 25 more kilometers. So when p will take a u-turn, q will be how far from p? I'll say 75 plus 25, that is 100. So I can say that now it's a case of what? Same direction. P is going to chase q, but the speed of p will become what? Upstream speed. That is, now the speed of p, effective speed of p will become how much? 25 minus 5, that is 20. Why? Because p is moving upstream and q is also moving upstream. So after how much time p will catch q? I'll say time is equal to distance, that is 100 kilometers is the gap between them. Fine. Divided by relative speed. The speed of p is, effective speed of p is 20, while the effective speed of q is only 10. So 20 minus 10 is 10. 100 by 10 will give you 10 hours. So can we add 10 hours here? Which will be wrong or right? You tell me. Because in these 10 hours, q will cover how much distance? 10 into 2.5, that is 25 more. And p will cover how much? These 25 and these 75. Speed of p is 20. That was 25 minus 5. So how many more hours are required for p? It's 10 hours. 10 hours after what? The first meeting point? No. How do we add it? They took how many hours to meet for the first time? 7.5 hours. After that, p traveled for how many more hours? 2.5 hours. After that, he needs how many more hours? 10 hours. So effectively, after 20 hours, they'll meet for the second time. 20 hours should be added in which time? What was the starting time? 3 a.m. So when you add 20 hours in 3 a.m., what you will get? It should be 11 p.m. I hope it should be 11 p.m. So my answer is what? 10:30 a.m. and 11 p.m. Is it clear? Yes or no? We need to add 20 hours. Now look at this. It should be 11 p.m. or not? We'll add it. 20 hours must be added in which time? 3 a.m. 3 a.m. plus 24 hours will give you what? Again 3 a.m. But I need to add only 20 hours, so I'll subtract 4 hours from this 3 a.m. So that will give you 11 p.m. So the correct answer is what? Second option. Let's look at the next question. Okay. The actual CAT question is taken from the CAT 2005 or 2006. It depends on what the time difference is. When you move from India to America, let's say the total time gap is, total distance will be covered in 12 hours. So can I say if you start at 10 a.m., you should reach at what time? 10 p.m. But if you look at the watch of America, it will not show you 10 p.m. It will show you 11 hours or 10 hours less than that, because America is 11 and half hours behind us. So there will be a time gap. So if you look at these two cities, when you move from B to A, the starting time is 8 a.m. and you reach at what time? 3 p.m. So it shows how many hours? I hope 7 hours only. But when you come back from B to A to B, it takes how many hours? 4 p.m. to 8 p.m. That means only 4 hours. How is it possible? The speeds were same, but the time taken is different just because of what? It's just because of what? The time gap. When you move from B to A, you take 7 hours. When you move from A to B, you take only 4 hours. And there is one more factor. Look at this. City A is 3000 km east of city B. This is B. This would be A. The following table describes the schedule of an airline operating non-stop flights between A and B. All the times indicated are local and on the same day. They are local. That means this 3 p.m. will be the local time of which city? A. And this 8 a.m. will be the local time for city B. The time should not be same because they lie in different directions of this different directions with respect to each other. Assume that plane cruise at the same speed in both the directions. However, each plane's effective speed is influenced by a steady wind blowing from east to west. That means wind is blowing from what? East to west. So first time I'll say A to B. So if you're moving from B to A, the wind will resist you. So effective speed will decrease here. And when you come back from B to A, the wind will support you. So effective speed will increase here. Fine. Now the time gap is not given here. How do we write it? B2A. Let's say city A is T hours ahead of city B. City A is T hours ahead of city B. That means if you're taking 7 hours, the effective time would not be 7 hours. It would be less than that. Because the clock of city A is T hours ahead of city B. That's why it will save you more time. And reverse will happen in case of what? When you move from A to B. Fine. Because B is T hours ahead of that. City A is T hours ahead of city B. How do we write the equation here? I can say that I have taken 7 hours here. No. Effective hours taken will be 7 minus T because city A is T hours ahead of that. So how do we write the equation? The first equation would be 3000 kilometers per hour. What is the relative speed? You're moving from B to A. What is the speed of plane? Is it given here? No. You need to find it. Let's say speed of plane is x. Fine. You're moving from B to A. So you're moving against the wind. So effective speed will become x minus 50. Because wind is against you, moving from B to A. And the time taken is 7 hours. But the actual time would be not 7. It would be 7 minus T. Because city A is T hours ahead of city B. Similarly, the second equation would be what? 3000. Now you're moving from A to B. That means east to west. Wind will support you, so effective speed will become x plus 50. This must be equal to how much? The time taken here is 4 hours, but the actual time would be 4 plus T. Because when you reach B, it will show you 8 p.m. And I know that B is T hours behind city A. So the effective time taken will become 4 plus T. So left with 2 equations and 2 variables. After solving this, you will get T equal to 1. That means the time difference between these two cities would be 1 hour. And the value of x would be 550 kilometers per hour. So the correct answer for both the questions will become C. Okay, let's look at the next one. Mr. Hudson started to move from Baker Street to Bristol. Okay. Exactly an hour after, Holmes started from Bristol in the opposite direction. Mrs. Hudson's speed was twice that of Holmes. When Holmes had covered 1/6 of the distance between Bristol and Baker Street, Mrs. Hudson had also covered the same distance. Okay, let's draw it like this. Let's say this is Baker Street, this is Bristol. Who will start from this point? Holmes. And this is Mrs. Hudson. She started exactly an hour after Holmes started, and both of them have covered the same distance, and that distance is given equal to 1/6 of the total distance. So let's say this total distance is D. So Holmes has already covered D by 6 and Hudson has also covered D by 6, although she started an hour later. So if I assume that Holmes has covered the whole distance in T hours, so Mrs. Hudson must have covered that distance in T minus 1 hours. And the speed of Mrs. Holmes is twice of Mrs. Hudson is twice of Holmes. So let's say speed of Mrs. Hudson is 2x and Holmes is x. So the distance covered is D by 6 with the speed of 2x in how much time? T minus 1. And this is D by 6 by x is equal to T. When you divide these two equations, what do you get? You'll get the value of what? T. D, this is equation number 1, equation number 2. When you divide equation number 1 by equation number 2, you'll get T equal to 2. That means Holmes must have traveled for 2 hours and Hudson traveled for only 1 hour. Yes or no? Since the speed of Mrs. Hudson was twice the speed of Holmes, I can say that the distance covered by Holmes in 2 hours was covered by Mrs. Hudson in only 1 hour. Now they have covered equal distance. How much distance is left between them? 2D by 3. Now if they start moving towards each other, obviously more distance will be covered by Mrs. Hudson. So that meeting point would be more closer to which station? Bristol. So my answer should be C. Because now the distance between them is 2D by 3. They've already covered the equal amount of distance. Now more part of this 2D by 3 will be covered by Mrs. Hudson. So meeting point would be somewhere here. That means closer to which station? Bristol. And how many hours would Holmes take to reach the Baker Street? This is the question. How many hours would Holmes take to reach the Baker Street? This is Holmes. He's already covered this D by 6 in how many hours? 2 hours. And if you want to cover the complete D, to cover D by 6 kilometer, you need 2 hours. So to cover D, you need how many hours? 12 hours. So the correct answer for this part becomes how much? 12. I hope this is clear to everyone. Let's move on to the next one. Okay, we have already solved a similar kind of question in sheet number 1, but the second part is new for us. Let's read this question. It's about a policeman, dog and thief. The theft is realized after 3 hours. That means thief will get these 3 hours extra. So what's the speed of thief? 40. So he'll create a gap of how much? 40 into 3. That is 120 kilometers. This is the initial position of thief. And this is policeman. So let's try to calculate the total time taken by policeman to catch the thief. He is going to chase the thief. So time is equal to initial gap by relative speed. Their speeds are 50 and 40. So 50 minus 40. This will give you 12 hours. So in 12 hours, policeman is going to catch the thief. And so dog will also get these 12 hours. What is the total distance traveled by dog? I'll say 12 into speed of dog is how much? 60. So he must have traveled 720 kilometers. So the answer for the first part becomes what? C. Well, now if you look at the second part, it states that find the total distance traveled by the dog towards the thief. He has traveled 720 kilometers. Out of that, some distance will be covered in the forward direction, that means towards the thief, and some part will be covered towards the policeman. Let's draw it in this way. He'll go and touch the thief. Then he'll come back. He'll touch the policeman. Then again he'll go back. He'll touch the thief. He'll come back. Touch the policeman. Then again he'll go. Something like this. So let's do it in this way. Let's say this is the catching point and this is the initial point. Let's mark it like this. A, B, C, D, E, F, G, H, I. So what's the total distance traveled by dog? I'll say AB plus BC plus CD plus DG, or I'll take it equal to DF. AB plus BC plus CD, then DF, then plus FG, yes or no, plus GH plus HI. This was how much? AB. Then I took it equal to BC plus CD, then DF, FG plus GH plus HI. And if you look at this figure carefully, you can say that BC must be equal to what? CD. Similarly, FG must be equal to GH. Yes or no? So let's assume that BC plus CD plus FG plus GH is equal to 2x. BC plus CD plus FG plus GH is equal to 2x. That means BC plus FG is how much? This BC plus FG is x. And left with what? AB plus DF plus HI. This is AB. Then the next one is DF, this one, and this one is HI. So can we say this is the distance traveled by policeman? He must have traveled AB, then DF, then the last one is what? HI. So AB plus DF plus HI is the distance traveled by policeman. I'll take it equal to Y. This was already equal to how much? 720. So how do we write it? Y plus 2x is equal to 720. And what is Y? It's a distance traveled by policeman. He traveled for how many hours? 12 hours. What was the speed of policeman? 40. So distance traveled by policeman will become 40 into 12. That is 480. So we'll get the value of x from here. I'll say 480 plus 2x is equal to 720. So I'll get 2x equal to how much? 240. So what is the value of x? It's 120. Now let's come to the question. Find the total distance traveled by the dog towards the thief. So he traveled how much? AB. This is towards thief. Then BC was towards policeman, but CD was towards what? Thief. Similarly, FG was towards policeman, but GH was towards what? The thief. That means this x, out of this 2x, which I counted as BC, CD, FG, GH, out of this 2x, half was covered towards policeman and half was covered towards thief. So the total distance traveled by dog towards the thief will be AB, then DF, HI, which was already equal to how much? 480. So this is 480 plus he also traveled BC plus FG, which is equal to x, 120 towards the thief. That is CD, this CD plus GH. He traveled BC towards policeman, but CD towards what? Thief. FG towards policeman, but GH towards what? Thief. So CD plus GH must be equal to what? Half of this 2x. So I'll take it equal to 120. So the total distance traveled becomes how much? 600 kilometer. So my answer should be third option. I hope this is clear to everyone. Let's move on to the next one. Okay, it's about what? 2%. M and A, they left simultaneously for Y and X, from X and Y. This is X, this is Y. The distance between X and Y is how much? 1000 meter. They'll keep on moving like this. They'll reach their destination, they'll take U-turn, then again they'll move towards each other's destination. So it's given that the ratio of Mary's speed to that of Adler is 3:2. So let's take it equal to 3x and 2x. Then find the distance traveled by Mary when she meets Adler for the fourth time. So let's try to calculate the time taken for the fourth meeting. Do you remember this general formula? 2n minus 1 into d by relative speed. That was speed of first person plus speed of second person. So time taken for the fourth meeting will become 2 into 4 minus 1 into d. What was d? The initial gap, 1000, divided by sum of their speeds. That becomes 3x plus 2x. So I'll get how much from here? This is 8 minus 1, 7. You'll get 7000 by 5x. This much time is required to meet for the fourth time. So what's the distance traveled by Mary in this much time? You know that distance is always equal to speed into time. What is speed here of Mary? Mary's speed is 3x. The time taken is 7000 by 5x. This x will be cancelled out. This will give you how much? 1400. And 1400 will be equal to how much? This was 3x into this x will be cancelled out. There is no x. 4200. Yes or no? So he must have traveled, Mary must have traveled 4200 kilometers. I hope this is clear to everyone. Okay, let's look at the next one. Okay, there are three friends. They went out for 100-kilometer journey. Two of them started the journey in car and one was walking at a speed of 5. After some time, John got off and started walking at the rate of 5. And Sherlock went back to pick up Mycroft. All three reached the destination simultaneously. Find the number of hours required for the trip. Let's do it in this way. This is 100 kilometers for me. Fine. Let's say they started from a point A and the final point would be B. So one person will be walking at a rate of 5. Let's say after T1 hours, John will get off. That means in those T1 hours, the person who was walking, Mycroft, will cover how much with a speed of 5? He must have covered 5 T1 distance. Let's say this is point B. And the two persons on a car, in a car will cover how much time, how much distance? Their speed was 25. So in T1 time, they must have covered 25 T1. So 5 T1 is already there. I'll add 20 T1 more. That is point C. So at point C, John will get off and he'll start walking towards what? The destination. Let's say Sherlock will keep on moving for T2 more hours to pick the second person, to pick the Mycroft. That means for T2 hours, this person who's at B, Mycroft, will cover how much? 5 T2. And Sherlock will cover how much? 25 T2. So this is 25 T2. And John will cover how much in T2 time? 5 T2. Now he'll reach at a point E when Sherlock will pick Mycroft at point E. Now all of them will start moving towards B and they'll reach simultaneously. Let's say they'll reach after T3 hours. So this distance will be covered by John in T3 hours with a speed of 5. So we can replace it by what? 5 T3. And Sherlock will start from point E towards B. Will cover how much distance with a speed of 25 in T3 time? 25 T3. So let's make the equation. Can we say 5 T1 plus 20 T1 plus 5 T2 plus 5 T3 must be equal to 100. This will give you 25 T1 plus 5 T2 plus 5 T3 is equal to 100. This is equation number 1 for me. The other breakup which I can see here is what? 5 T2 plus 25 T2. This one must be equal to 20 T1. So directly I write 20 T1 must be equal to 30 T2. That means T1 by T2 becomes how much? 3 by 2. So I got the ratio of these two times. One more equation is there. Can we say this 25 T2 plus 5 T2 plus 5 T3 must be equal to 25 T1? Let's write it like this. 25 T2 plus 5 T2 plus 5 T3 must be equal to this complete 25 T3 which was covered by Sherlock in the last T3 hours. So after solving this, what you'll get? 30 T2 is equal to 20 T3. Yes or no? 5T goes on that side. So T2 by T3 becomes 2 by 3. And we know that T1 by T2 was what? 3 by 2. So can we say T1 is to T2 is to T3 is equal to 3 is to 2 is to 3. Let's take this time in terms of x, that is 2x, 3x, 2x and 3x and put the values in this equation. So what will say? 25 T1 plus 5 T2 plus 5 T3 is equal to 100. What is the value of T1? 3x, and put 3x in. So it becomes 75x plus 5 T2 means 5 into 2x. I'll get 10x plus 5 T3. So I'll get 15x more. This must be equal to 100. So overall I'll get 100x is equal to 100. That means x is equal to 1. If x is equal to 1, I can say T1 is 3, T2 is 2 and T3 is 3. So the total time taken will become 3 plus 2 plus 3. How many? 8 hours. They'll finish the journey in how much time? 8 hours. Fine. Okay, let's look at the next one. Sherlock is traveling in a car at a speed of 72. Let's convert this in terms of meters per second. I'll get how much? 20 meters per second. Because when you multiply it by 5 by 18, you'll get 20. And this will give you 36 into 5 by 18. That is 10 meters per second. So Sherlock's speed is exactly double of Moriarty. Okay. He spots a man on the other side of the road. Let's say this is a road. There's a parallel road. Sherlock is here. And this is M. So he'll spot him at this point. Now what he needs to do? He needs to take the U-turn. And it cost him how much? 6 minutes. So if Sherlock wants to reach here, he needs 6 minutes. In those 6 minutes, this person M will cover how much distance? What is the speed of this person? 10. 6 minutes means 6 into 60. 360 seconds. So in these 360 seconds, distance covered by m will become how much? 10 into 360. That is 3600. Am I right? So by the time Sherlock will reach at point A, M will reach at which point? B, which will be 3600 meters away from them. Now what's the final part? Sherlock wants to catch M. M is at B. Since they are moving in the same direction, what will happen? Time is equal to distance by relative speed. That is 20 minus 10. It will take how much time? 360 seconds. Yes or no? 360 seconds means how many minutes? 6 minutes. So Sherlock needs 6 more minutes. And after how much time from spotting he'll catch him? So he took 6 minutes to take a U-turn, and after that he needs 6 more minutes. So effectively total time required will be 12 minutes. So my answer becomes first option. Okay, let's look at the next one. Two cars simultaneously left two cities, Norfolk and Hampshire. Okay, left two cities. First one is N, next one is H. So I'm moving towards H and the other person will move from H towards N. Once they reach their respective destination, they turn around and move towards their starting point. They met for the first time 22 kilometers from the Hampshire. So the total gap between them is d kilometer. First time they'll meet at what? 22 kilometers from Hampshire. So this distance will become d minus 22. Yes or no? They'll reach their destination, then they'll take U-turn. And the second meeting will be 10 kilometers from N. So this is 10. This remaining will become d minus 10. Let's try to find the ratio of their speeds. Can I say by the time first person will cover d minus 2, this point is P. By the time first person will cover d minus 2, second will cover only 22. So the ratio of the speeds will be equal to ratio of the distances traveled. So let's say d minus 22 by 22 must be the ratio of their speeds. I'll reach at point P and I'll keep moving towards what? The Norfolk. So what I'll do, I'll cover these 22 kilometers, then I'll take a U-turn and I'll come d minus 10 more kilometers. By that time, what you'll do? You'll reach at this point and again you'll take U-turn and you'll cover 10 kilometers more. So this would be our second meeting. So can I say by the time first person will cover 22 plus this d minus 10. So 22 plus d minus 10. Second person must have covered this d minus 22 plus 10 more in the reverse side. So d minus 22 plus 10 more. Can I say like that? Yes or no? They met at the first point, this one. This is the second meeting point. So the ratio of the distances traveled must be equal to ratio of speeds. So this is the ratio of speeds in the first case, this is the ratio of the speed in the second case. But this ratio will remain constant. So let's equate them. So this becomes d minus 22 by 22 is equal to, this is how much? D plus 12 and this would be d minus 12. And when you cross multiply them, what you will get? D minus 22 into d minus 12 is equal to d plus 12 into 22. You get d square here, minus 22d and minus 12d, that is minus 34d. And then we'll have plus 22 into 12. This would be 22 into d, 12 into 22. I can easily cancel out these two terms. So I'll be left with what? D square is equal to 34 goes on that side. It becomes 56d. So 1 dt will be cancelled out. I'll get d equal to how much? 56 kilometer. So my answer becomes second option.